0, and that is the rate of step 1 minus the reverse rate of step 1 minus the rate of step 2. You can substitute in again, that's equal to 0. So you rearrange to solve for the radical. And that's what you get. R1 minus, so where did I mess up here? Yeah, thanks. Now you got 5 points if you got these, which is rather generous, I think. Yeah.
Is it on the bottom of the last equation we wrote? Is it K1 or K negative?
The bottom is K negative 1.
Yeah, it's in there, but it's like it ran into the bottom of the K. I probably left it out the first time and then tried to add it back in a little sneaky. Just trick myself. You get 5 points for this, and you got 5 points for this. You could have stopped the problem right there. That's not to say that continuing doesn't make the rest of the problem easier. It does. Or sorry, you actually do have to substitute that in to this equation. And then you get the 5 points. But you didn't have to simplify as promised, although it does make the rest of the problem easier. So when we substitute in, without any simplification, you get this. Well, with only a minor amount of simplification, I guess I'd say. That is just that expression. Everything in that big parentheses is just O dot. Yeah?
If you made a mistake of like the first line, writing the rate law for O3, say like you forgot like the reverse, does that carry, like do you get penalized every time you write that? Is it double penalizing?
It depends. If it's what I told the grader. All right, so first let's say something more procedural. If you have an issue with how your test was graded, I will grade it. I will grade the entire test. So there's a slight risk, but I kind of have to do that, otherwise I'm going to get 134 regrade requests if there's no risk to you. If the mistake is fairly large and conceptual, like you forgot that there was a reverse reaction when you were told there was a reverse reaction, you might get dinged in a few places for it, yeah. If you forgot a minus sign, probably not. So there is some subjectivity to it. It depends on the nature of the error.
So it does like carry, like you lose points every single time?
Yeah. It depends, like I said, it depends on the nature of the error. I mean, just to give you a counterexample, I could have wrote the rate of all three of those reactions was 0. I get to the next part, rate's 0. I get to the next part, rate's 0. And you're going to tell me you can't lose points on the subsequent parts if you just write something nonsensical to start. I'm not saying you did that. I'm just saying that that type of thing can easily be abused. So again, it depends on the nature. I don't want to make simple mistakes hurt you throughout the entire problem, and I don't think they did based on some of the graded exams I looked over. But if it's something big, then it can hurt you in multiple places, yeah. Okay, anyways, that's what you get. And again, you didn't have to simplify this, and you would have gotten the rest of the 5 points for part A. Part A, I don't know if they had, no, they didn't. Part A was worth 15 points. Of course, you can keep going, and it helps solving the rest of the problem. And what this actually simplifies to is this expression. So that's actually the final expression if you were to continue to simplify the algebra. Any questions? Okay. That was a fairly straightforward problem. I don't think a lot of people lost points. Where they did, they might have forgotten that it was reversible or something like that. But otherwise, I mean, the average on this first problem, I think, was a 25, or the median was a 25 out of 30. That's a pretty good average. Okay, part B. Sketch a qualitative plot showing the rate of ozone decomp versus ozone pressure. If there's more than one regime, label the regimes with the apparent rate orders. So this one was really confusing me. Some of you got here and then couldn't do this part. So, I mean, I can get the unsimplified expression is nasty, and so it may not be obvious what the orders are. But I thought this one was pretty simple. Okay, so if I'm at a low concentration of ozone, which term in the denominator do I remove? Right. And so is it first order or second order? Second order. Right. And so because I don't trust you guys' ability to draw, this is why I said label, because it is hard to draw this one. But here you would have second order and O3. At large ozone concentrations, we cancel out the other term, right? And the reaction becomes what? Okay. So there you get a straight line. And again, putting the label makes sure that you don't have to subtly draw. It's not an easy transition compared to like first to zero. That's pretty simple, right? So this one's a much more subtle transition, but that's why I said just label the regime so that you didn't have to be a great drawer. So any questions on this? Again, it's not nearly as easy to see up here, which is why we were fairly lenient in the grading of this part. Because if you didn't do the simplification, it would make it harder to see what the regimes were. Okay, in part C, under what conditions, and it wants a mathematical inequality, can we treat reaction 1 as quasi-equilibrated? And then it just says comment on the appropriateness of that assumption if the reaction is occurring in the atmosphere. Okay, so these are the two sort of important things that we have to compare. And so what you get is that if that's the inequality that you needed to get full credit. So you can think about it in a few ways. One, if you have this expression, then the only way that you can be quasi-equilibrated is if the rate constants for the first term have disappeared, or they're only present in their ratio, which means that you could have substituted in the equilibrium constant. You could have also re-derived the rate by making the assumption that step 1 is quasi-equilibrated and then come up with a new derivation and see under what conditions will it match that. So I did that here just to kind of show it, but what you get is, so if we assume that that's equilibrated, then we can write that the concentration of O star is equal to, I thought I had this in my notes. Yeah, it's going to be, let me think. I'm just trying to remember if it's 1 over K1. All right, let's write it this way. O star times O2 divided by O3. So yeah, this is equal to K1 times O2 divided by O3 divided by O2. And so you could have plugged this back into here, wherever you had O star. I didn't write it out. I mean, I did, but then I, substituted in. So instead of substituting in from the pseudo-steady state approximation, you could have substituted in from there. But another way to look at it is, if I have two reactions, this would not be a quasi-equilibrated reaction because the rate forward is faster than the reverse rate. What you need for quasi-equilibrium is that the forward rate is slower than the reverse rate, which means that this first reaction will go back and forth maybe 1 million or 1 billion times for every one time that you actually are able to go from B to C in that example. Okay, so again, that's the inequality, and then the question about, what is the, and you guys would get partial credit if you put only the pressures instead of the rate constants. But technically, to be correct, you do have to take into account those rate constants. And it asks, sort of comment on the appropriateness of that assumption when it's occurring in the atmosphere. So in the atmosphere, the concentration of O2 is much, much larger than the concentration of ozone. So it is an appropriate assumption. And so again, what it ends up